After then you are summing for summing the all the values, correct, of the alternatives squared. Then you are square rooting it, and then you are dividing it from each of the value of the alternative only, not the square of the values. You see here it is written xij, so the only the value, not the square. Mind it. Okay, then you find the rij, sorry, which is the element which denotes the element of the vector normalization or normalization matrix. Okay, so the second step is complete. Now we'll move into the third step. Now apply criterion weights. This is a very interesting thing. This is totally depends upon the decision maker by itself. Here we assign weights to the criteria. We have two criteria. We can assign two weights, but the condition is summation of your weights will be equals to 1. And each of the weight must be greater than or equal to 0. So let it be C1, the cost criteria 0.7, C2 0.3. So the summation will be 1. Correct? So this condition you have to make. You can assign any weights which is proportional to the importance of the criteria with respect to the decision maker. Okay. So here you can just directly give the or allot the weights from the decision maker, or you can use the weights of criteria as determined by the AHP method. First step, refer to my video tutorial on AHP, analytical hierarchy process, or you can use some technique known as entropy weighting. That is also you can do. For this, there is no role of decision maker if you use AHP and entropy. But when you are direct weighting, then there is a stakeholders, decision makers. There is a impact of decision makers. So generally what happens is we create a group of decision maker where multiple experts or stakeholders are there. We ask them to rate each of the criteria in a scale of 100. More the points or more the score you give, more important is the criteria. Correct? So after getting all the scores, we average it to find the overall or on a resultant weightage of the criteria. This weightage is directly proportional to the significance of that criteria. Okay, so both the methods you can use. If you use direct weighting, there is human bias. If you change the nature or type of the stakeholders, it will yield a different weight. But if you remain with that, it will always give you the same weights. But in case of HP and entropy, there is no chance of human bias. Always the weights will be same. Okay, so now let us go to the next step. Now, from the very beginning of the presentation, I was always saying the ideal solution, the ideal solution, the ideal solution. But what is it actually? So there are two positive ideals, two ideal solution. One is positive ideal solution. Another one is negative ideal solution. Now, what happens is in positive ideal solution, you will collect the best among the alternatives. And in case of negative ideal solution, you will collect the worst among the among all the alternatives. So let us draw the normalized matrix once again. So A, B, C, C1, C2. So let us say after normalization for C1, the values of AI is like this. This is not exact value. I am repeatedly saying this is just for example. So what will be the value? Let me see. It is be 0.71, 0.21, 0.10 like this. For C2, it will be suppose 0.52, 0.71, say 1 1 like this. These are arbitrary values, but it will come after you determine the normalized matrix with the help of the process I have explained just in the previous slide. Okay, now from here you see this C1 is the cost criteria. This is cost and also it's a cost criteria. That means more the value, lesser will be the preference. And this C2 is the benefit criteria. More the value, more will be the preference. So from C2 and C1, you will have to collect the best value. Now in case of C1, lesser is preferred, less score or less value of less performance value will be preferred. That's just the main thing is less cost will be preferred. So by showing by comparing the normalized value of A, B, C, you can understood that this is the best. That is indicated by green color. This is the best because this is the lowest for the cost criteria. Okay, so it is a cost criteria, so the best will be the lowest value and the worst will be the highest value. I am coming for the worst later on. But for C2, it is a benefit criteria, so the highest will be the best criteria, best value. So this is the highest value and this is the best value. So this best value of both C1 and C2 becomes the positive ideal solution. Okay.